Hello everyone and welcome back to the Math Pundit. Today I'm going to be going over how to solve for a variable when there's multiple steps involved. This topic is slightly more difficult than the previous ones, but as always, if you find that you need some extra practice with these types of questions, I have linked a practice worksheet and a key in the description below. Okay, let's go. Question 1. 3 is added to a number, and then the sum is multiplied by 4. The result is 16. Find the number. Okay, let's take this step by step. 3 is added to a number, so 3 plus x, and that sum is multiplied by 4. So this entire thing, that sum, is multiplied by 4. And the result, they said, was 16. So let's figure this out layer by layer. The first or outermost layer that I see from this equation is this 4 right here. We have to get rid of that 4, and then we're one step closer to isolating the x. Because 4 is being multiplied to the 3 plus x, that inverse function then is going to be division. So I'm going to divide both sides of the equation by 4. So if we go ahead and do that, we're going to get 3 plus x equals 4. Now, I'm going to have to get rid of that 3. And because it's being added to the x, I'm going to have to subtract. So minus 3 on both sides of the equation. Now, we get x is equal to 4 minus 3 is 1. So x is equal to 1. All right, let's move on to question 2. A number is divided by 4, and the quotient is added to 3. The result is 24. So a number is divided by 4, and that quotient is added to 3. And that equals 24. The outermost layer I see in this equation is the 3, and because it's being added, I'm going to subtract. So minus 3 on both sides of the equation. So we get x over 4 equals 21. Now the outermost layer is this 4, and because we're dividing by 4, I'm going to multiply both sides by 4. So x over 4 times 4, and 21 times 4. From this, we get x, where we finally isolated it, and then 21 times 4 is 84. And that's your final answer. Now, let's move on to question 3. The first layer I see in this is this minus 19. So I'm going to add 19 to both sides to inverse that function. So plus 19, and you get negative 12n is equal to 96. And now, because this negative 12 is the outermost layer of this equation, we're going to divide by negative 12 because it's being multiplied. So divide by negative 12 and divide by negative 12. The answer we're going to get is n is equal to 96 divided by 12 is 8, but since we're dividing by negative 12, the answer is negative 8. Okay, now let's move on to question 4. Negative 32 minus 3/5 f is equal to negative 17. So the first thing I see here is this negative 32, so I'm going to go ahead and get rid of that. Because it's negative, I'm going to add 32 to both sides. And we get negative 3/5 f is equal to 15. Now, the outermost layer is this negative 3/5. So how do I get rid of that? Well, we multiply by the reciprocal of the fraction. You could also divide by -3/5, but I find multiplying by the reciprocal easier. So that's what we're going to do. So here, we're going to multiply by -5/3, and multiply here by -5/3. From this, we get f isolated successfully, and then 15 times -5/3, once you solve it out, is -25. And that's our final answer. Question 5 is slightly different. So the first thing I see here is this 5. We want to get rid of that. And because we're dividing, so 3k minus 7 divided by 5, I'm going to multiply both sides by 5. So times 5 here and times 5 here. From this, we get 3k minus 7. 16 times 5 is 80. And the next layer is minus 7. So to get rid of that, I'm going to add 7 on both sides. So plus 7 here and plus 7 here. And we get 3k is equal to 87. And then last but not least, the last layer I see is this 3. And because it's 3 times k, I'm going to divide because that's the inverse function. And we get k. And 87 divided by 3 is 29, so k is equal to 29. Okay, last but not least, question number 6. Question 6 deals with something that we have to come up with on our own, this equation. It's not really explicitly given to us. It says find 3 consecutive odd integers whose sum is 117. So the key words here are consecutive and odd. So odd just means that each integer is 2 apart from one another. So 3 consecutive odd integers means it's going to be some x, that's your first integer, plus x plus 2 is your second integer, and x plus 4 is your third integer, and all of those added together equal 117. Now, the reason it's x and x plus 2 and x plus 4 is because every odd integer is 2 away from the integer before it. So 1 is an odd integer, and the next odd integer is 3. The next odd integer is 5. Both of those are plus 2 away from the previous one. 1 plus 2 is 3. 3 plus 2 is 5. 5 plus 2 is 7. And all of those are odd integers. Okay, so let's actually solve this. X plus 2 plus x plus 4. Let's combine all these like terms. We're going to get 3x plus 6 equals 117. Now, let's do this layer by layer too. 3x plus 6, I'm going to get rid of this minus 6 here, plus 6 here. So I'm going to subtract 6 from both sides. And we get 3x is equal to 111. Now, if we divide both sides by 3, because 3 is being multiplied by x here. So if we divide both sides by 3, we're going to get x is equal to 37. Now, we're not finished though. This is just our first integer, but it says find 3, all 3. So the first integer is 37, and we already know that the second integer is x plus 2. So 37 plus 2 is 39. And the fourth integer is x plus 4, and 37 plus 4 is 41. And those are our 3 consecutive odd integers.